December 2017. Question 3B. That is where we begin. So the question says, the management of New Era Computer Systems Limited is planning to launch a new product branded Zimsang. The fixed cost of Zimsang is 80,000 shillings. However, the selling price, variable cost, and annual sales volume of Zimsang are uncertain. The data below relates to product Zimsang. So we have the unit selling price, the variable cost, the sales volume. You are required to simulate the average profit of product Zimsang on the basis of 10 trials, and you use the following random numbers. So that question is on simulation. That question is on simulation. And you know, when we talk about simulation, we talk about, or we begin with what we call Monte Carlos. So we are going to have Monte Carlos. Let us draw Monte Carlos. So the first one is Monte Carlo. Monte Carlo for selling price. Monte Carlo for selling price. So Monte Carlo for selling price, we will have shillings here. Then we have the probability. We have the cumulative probability, and we have the range. We have the range. The selling prices are 60, 80, and 100. Probabilities are 0.25, 0.45, and 0.30. How to cumulate the probabilities? It is 0.25, 0.70, and 1. I believe that we are all comfortable with how to do the range, but if you are not, you can let me know. So this one is 00 up to 24. This is 25 up to 69. This is 70 up to 99. 70 up to 99. Then we come and do Monte Carlo. Monte Carlo for variable costs. Monte Carlo for variable costs. Again, we have shillings. We have the probability. We have the cumulative probability. And we have the age. So this is 20, 40, and 60. The probabilities are 0.25, 0.55, and 0.20. So 0.25, 0.80, and 1. 00 to 24, 25 to 79, 80 to 99. And then we get Monte Carlo. Monte Carlo for sales volume. Sales volume. So this one will be shillings. We have the probe. We have the cumulative probe. And we have the range. We have the range. So, no, sorry, these are not shillings. These ones are units, sorry. These ones are units, not shillings. So these are units. Units. So the units are 40,000, 60,000, and 100,000. So this will be 0.30, 0.35, and 0.35. So 0.30, 0.65, and 1. So 00 to 29, 30 to 64, 65 to 99. 65 to 99. Okay, Ariana, I can see. That's good. Okay, then I'll go back to 2E once you are through with this one. I'll go back there. But for now, we finish on this one. So after the Monte Carlo, we are supposed to draw the simulation sheets. We're supposed to draw the simulation sheets. And remember, this is also what we call the logic. It's also what we call the logic. So we are told to do 10 tracks. So we will have trial number. Trial number. Then we will have selling price. Selling price, we have random number, and then change, which I will call A. We'll call A. Then variable costs. Variable costs, we have random number and then series. which we will call B. Then sales volume, random number, which will have units, and these units will be thousands. And we call them C. These units, they will be thousands, and we will call them C. Then I will have fixed costs, again in thousands, and we call it D. And then I will have profits. And profit will be A minus B. You multiply by C minus D. Looks like that bit is not very clear. This one. So this is A minus B. We multiply by C minus D. Hope that is now visible. So ukishamaliza kuchora hiyo table, you say finished, you write finished. Ukimaliza kuchora, you write finished. Yeah, finished. Okay, so if you are finished, then we can begin the analysis. We can begin the analysis. So this is what we do. You take the first random number, 81 here. So when you have 81 there, you come to the Monte Carlo here for the selling price, that is 100. That is 100. Take the next random number as that's 2. That's 2, but there is no harm kama ungeamua kuchukua vertical, still okay. So that's 2, ukikuja hapa, it is between 25 and 79. So that gives us 40. That gives us 40. The next random number is 60. So 60 is here. 60,000 units. Remember, we are saying they're in thousands. Then for the fixed cost, we are told it is 80. So use this formula and give me the profits. Use the formula and give me the profits. Use the formula and give me the profits. What is the answer? I'm waiting for the answer. What is the answer? Aris, you are saying 352,000. That is 100 minus 40 equals times 60 minus 80. That 520. Good. So it's 3,520. That is what we have there. $520. The next one, the next random number is 04. So number 2, 04. 04, when you come here, it is 60. 60. The next random number is 16. 16. So 16 ukikuja hapa, it has a variable cost of 20. The next random number is 31. 31 ukikuja hapa, it is 60 also. And the fixed cost is 80. So work out that and give me the answer. Useme 60 minus 20 equals times 60 minus 80. Give me the answer. You are saying it's 46, not 16. Oh, it's 46. Sorry. 46. So that one will change. So 46 tukikuja hapa, it is here, so it will give us a 40. So this one will be 40. 40. So give me the new value from there. Give me the new answer from there. Alice and Eliana, you are differing. Check whether you have adjusted. It's supposed to be 60 minus 40 equals times 60 minus 8, 11, 20. So Eliana, check yours. The correct answer is 11, 20. Eliana, have you rectified that? Yeah, good. Let us go to the next, number 3. Number 3, after that one, I have 67. 67. When I'm here, it is going to give me 80. It is followed by 25. 25 here is giving me 40. And then 24. 24 is giving me, when I come here, it is 40. And the units are 8, the fixed cost is 80. So send me the answer. Send me the answer as 80 minus 40 times 40 minus 80. Send me the answer. Yes, Alice, 1520. 1520,000. So it's 1520. Remember, the profits are also in thousands, according to my workings. Then we go to day number 4. When I go to day number 4, after 24, it is 10, 40, 02, 10, 40, and 02. Those are the random numbers. So then, when I'm here, it is giving me 60. 40, when I'm here, is giving me 40. And 02 down here is giving me 40. And the fixed cost is 80. The fixed cost is 80. So send me the answer. Ali says, yes, Rihanna, 720. Good. 720. The next one, number 5, that was 02, figure 02. Now I pick that 9, 68, and 08. So that 9 here gives me 80. 68 here gives me 40. And 08 gives me 40. And the fixed cost is 80. So according to Alice, 1520. Eliana, good, 1520. We go to number 6. Number 6, ilikuwa nimefika 08. So now ni 59, 66, and 90. So 59 here is giving me 80. 66 here is giving me 40. 90 is giving me 100. And the fixed cost is 80. And the fixed cost is 80. That 920, according to Rihanna. Yes, Alice, at 920. At 920. Day number 7, 12 here, 64, and 79. So 12 has 60. 64 equal to 40. 79 equal to 100. And this is 80. That is 80. 1920, according to Alice, Rihanna, good. 1920. Day number 8. Day number 8. After 79, I have 31, 86, and 60. Sorry, this is 86 here, and 68 here. So that one here, I have 80. 86 here, I have 60. 68 here, I have 100. And this is 80. You are saying 25, not 68. My table is after 86, I have 68. So Eliana, maybe yours is wrong somewhere. Aris, are we okay from the table you have? Are these numbers okay? That's 1, 86, 68. Yeah, so Eliana, we are okay. Maybe somewhere there is. Oh, now I can see you are agreed. Okay, now give me the correct answer now. The correct answer, Muko? 1920. Okay, good. Number 9. After 68, I have 82, 89, 82, 89, and 25. So 82 here is giving me 100. 89 here is giving me 60. And 25 is giving me 40. And this is 80. So R is okay, 15, 20. What can you give it? 15, 20, good. Day number 10. Day number 10, it is after my random number of 25, I have 11, 98, and 16. So 11 here is giving me 60 as a selling price. 98 here is giving me 60 as the variable cost. And then 16 here is giving me 40. And this one is 80. So send me the figure. Minus 80. Minus 80. So with that, give me the total of this. Total. Add all those profits. You give me the total. 17,600 according to Eliana. 17,600. So the average, you divide that by 10. So it will be 1760. It will be 1760. Alice, are you able to confirm that total? Okay, so I think we are okay. So if we are okay, we proceed to the next question. So we go back to question 2E. Question 2E. That question is so question 2E. The demand and total cost functions in thousands of shillings of a certain company that deals in the manufacture of a product named X are given as follows. So we are given that, and you are required the profit functions and the output level that maximizes profits. So that question is on functions. Is on functions. The question is on functions. And I told you when you're told to get profit, you begin by saying that total profit is equal to total revenue minus total cost. Total revenue minus total cost. That is how you begin. You start now looking for total costs. So you say that total costs should be equal to, is actually given as 80Q. I don't know whether that is minus or plus 5Q squared minus 0.03 Q cubed. Then for the total revenue, it is the price which is given as 75 minus 0.18 Q. You multiply by Q. When you multiply by Q, this stands to be 75Q minus 0.18 Q squared. That is the revenue function. So that means that total profits will be equal to 75Q minus 0.18 Q squared. You minus the cost function, which is 8Q plus 5Q squared minus 0.03 Q cubes. So pi, if you open the brackets here, you have 75Q minus 0.18 Q squared minus 8Q minus 5Q squared plus 0.03 Q cubes. That is the function. When you put right hands together, this 75 joins this 80, so that we are left with minus 5Q. This 0.18 joins this, so that we are left with minus 5.18 Q squared plus 0.03 Q cubes. Then you say for maximum profits, the differential of pi with respect to Q should be equal to 0. That is, the differential of pi with respect to Q should be equal to 0. We differentiate this, and I'm left with minus 5 minus 10.36 Q plus 0.09 Q squared is equal to 0. Are we together up to that point? Yes, Ariana. Alice, Are we together? Hope Paris is still in class. Oh, good. So, good. Right. So if we are together, then we say using quadratic formula, using quadratic formula, we know that Q will be given as minus B plus or minus B squared minus 4AC. This one, you get the square root. You get the square root. And then you divide by 2A. You divide by 2A. So this becomes Q is equal to minus B. B is this one, so it becomes plus. So we have 10.36 plus or minus 10.36 squared minus 4 times A. A is 0.09 times C, which is minus 5. Then all this, you get the square root. Two times A, 0.09. So this is 10.36 plus or minus. Plus or minus. So this one we will say 10.36 squared. It will actually become plus 4 times 0.09 times 5. Square root of that is 10.45. So 0.18. So I'm going to end up with something like this. 10.36 minus 10.45, you divide by 0.08, or 10.36 plus 10.45, 0.18, 0.18. So now 10.36 minus 10.45 divided by 0.18 is minus 0.5, or 10.36 plus 10.45 divided by 0.18 is 115.61. So this one, we can now get to 116 units. We can now get to 116 units. Yes, Ariana, good. So with that, the question had asked us, or we have answered because we have been taught to get the output level that maximizes the profits. That maximizes the profits. That maximizes the profits. So are we okay with that? Are we okay? Okay. So if we are okay, so the next thing, is December 2017, question 3. A and B. Now these ones, they have come from regression and correlation theory. Regression and correlation theory. That is where they are coming from. Regression and correlation theory. So we are taught to distinguish between regression analysis and correlation analysis. So we will say regression analysis is a set of, or is a statistical technique. Used to study the strength of the relationship, existing between variables. That is what we call regression analysis. It is the study of the strength of the relationship that exists between variables. The next one is correlation analysis. So correlation analysis is a statistical technique. Used to study the type or the nature stroke type of the relationship existing between variables. So that is what we call the correlation analysis. It is the study of the nature of the relationship that is existing between variables. The other thing is applications. You are told to cite applications of rank correlation. Applications of rank correlation. So in the applications of rank correlation, it is the same thing here. One, study of the strength of relationship between variables. That is the first application. The second application is just this one. It is the study of the type of relationship. The relationship between variables. The relationship between variables. So those are the two applications that you can find of the rank correlation. Now, part C of that question, it is the conversion of an exponential function to a regression function, and that bit is not part of your syllabus. So whoever brought it there, it was by mistake. We are not supposed to teach you how to convert exponentials to regression and vice versa. So I will not take time to do that. So are we okay with that? We proceed to question 4 now, because 3D we have solved. Alice, are you okay with that? Good. Let us now proceed to question 4A. Question 4A. In a certain business facility, the mean arrival rate of clients is 800 clients per hour. The mean service rate is 820 clients per hour. The facility operates between 6 a.m. and 6 p.m. The management of the facility are concerned about the average number of customers in the queuing systems and wish to improve the facility in order to serve an average of 8.7 clients per hour. The cost of improving the facility amounts to shillings 18,500 per day. Each hour lost costs the facility shillings 125. So the first thing we are told is average waiting cost per day. Average waiting cost per day. So that question the December 2017 question 4A, it is coming from what we call queuing theory. It's coming from queuing theory. And I have been telling you that every time you are dealing with a question, you must identify the background or the analysis. Let me call it the background. The background of the question or the characters. Let me call it the characters instead of the background. The correct word to use is more the characters. What are the characters of that question? You must identify the characters of the question. And the characters, I told you number one is the channel. Is the channel. Yes, Eliana, I skipped 3C because I said it's no longer part of your syllabus. It's no longer part of your syllabus. We are not supposed to teach you how to convert exponential functions to linear functions. Is that okay, Eliana? Are you okay with that? Okay. So it should not stress you anymore. It's not part of your syllabus. Maybe you come across it if you are doing basic mathematics at the higher level. You are doing mathematics at the higher level. So back to this one. We need to know how many channels are there. How many channels are there? So the question is just talking of one facility. So it's talking of one facility. There is just one facility, so it's just one. The second thing is to identify the arrival rate. The arrival rate. We are told clients arrive 800 clients per hour. So it is 800 clients per hour. 800 clients per hour. The next one is mu. Mu, the service rate. The service rate, we are told it is 820 clients. 820 clients per hour. 820 clients per hour. So when you are told to get the waiting costs, if you are told to get the waiting costs, if you are told to get the waiting costs, the waiting cost we say it is computed as relevant waiting time, you multiply by arrival rate, you multiply by arrival rate, you multiply by waiting costs per unit of time, you multiply by the relevant duration. The relevant duration. You multiply by the relevant duration. So that is how you get the waiting cost. It is the relevant waiting time times the arrival rate times the waiting cost per unit of time times the relevant duration. So in our case here, the relevant waiting time in this case, relevant waiting time. I told you there are two types. There is a time in the queue and there is a time in the system. So if you look at this question, it is they are only concerned with the total time, because they are saying the management is concerned about the average number of customers in the queuing system. So if it is the queuing system, it is our WS, the time in the system. And you know WS is given as 1 out of mu minus lambda. Mu minus lambda. So this then will be 1 out of 820 minus 800. So we can leave it that way, then we come to simplify it here. Thus, waiting costs will be equal to 1 out of 20, because this will be 1 out of 20, 1 out of 20 times the arrival rate, which is 800, times the waiting cost. It is costing the facility 125 per hour, and we are told this facility is open from 6 a.m. to 6 p.m. Those are 12 hours. Those are 12 hours. So work out that and give me the answer. Work out that and give me the answer. Work out that and give me the answer. If you have any query, you raise. According to Ariana, we have 60,000. Alice, what are you getting? Okay, so it's also confirmed 60,000. Advise the management on whether they should improve the facility. So we can say, after the improvements, after the improvement, relevant costs, rather, let me go straight and still put it that way. Relevant costs will be equal to, after we do the improvement, we will now take 847, or we'll be able to solve 847. So 847 minus 800, that way, multiply by the arrival rate of 800, multiply by 125, multiply by 12, then you add the cost that will be incurred to do the improvement, which is 18,500. 18,500. So that we compare the costs. You add so that we compare the costs. Rihanna, you are saying 44,002 shillings. Alice, confirm. 44 and that's 2 shillings. Yeah, so it is the same. That's 2. So from there now, you will say the advice. The advice is undertake the improvements, undertake the improvements, since there is a saving. There is a saving of 60,000 minus 44,002. There is a saving of 60,000 minus 44,002. 15,968. 15,968. So that is the advice that we should render to that company. We are okay with that. The next thing to naulizwa, compare the probabilities that the total number of clients in the queue and those being served is greater than 17 in existing and in improved facilities. So first of all, we need to write So the formula of the probability the formula of the probability, you remember we said probability that n is greater than k is lambda out of mu u raised power k plus 1. U raised power k plus 1. So now the improvement here. So before, probability of more than 17 customers, probability of more than 17 customers more than 17 customers. So before it will be lambda here is 800. You divide by 820. This one you raise power 17 plus 1. And then after it will be 800. You divide by 847. You raise power 17 plus 1. You raise power 17 plus 1. So give me those probabilities. Okay, Rihanna 0.64 and 0.36. 0.64 and 0.36. Alice, is that okay? Yeah, good. So here tumemaliza. Let us now proceed to the next. Let us proceed to the next question. That says that two airlines, K and Q, are interested in increasing their market shares. Airline K has 3 available strategies: advertising its special fare, advertising its unique features, or advertising its safety record. On the other hand, Airline Q also had 3 available strategies: to do nothing, advertise its special fare, or advertise its special features. The matrix below shows the gains and losses associated with the different available strategies in millions of shares. Positive values favor Airline K and negative values favor Airline Q. So we are given that, and then we are told to get the optimal strategies for each airline and the value of the gain. and the value of the gain. So that question of December 2017, question 4B is from what we call game theory. Is from what we call game theory. Game theory. So the first thing is to come up with the matrix. Is to come up with the matrix that is already given there. The matrix. So we have K1, K2, and K3, and this is ARI K, ARI K. Then we have Q1, Q2, and Q3. This is ARI Q. ARI Q. The pairs are minus 30, minus 40, and 80. We have 0, minus 15, and 20, minus 90, minus 20, and minus 50. Minus 50. So I told you the first thing is to start. Once you start, you check whether there is a saddle point. And the saddle point is checked this way. You come to this side, you extract the maximums. So the maximum here is 80. The maximum here is 20. And the maximum here is minus 20. And then I told you this bracket on this side, they use what we call min-max strategy. Min-max strategy. Min-max strategy. So minimum strategy means you will go for the minimum of the maximums. The minimum of the maximums, which happens to be this one. That is what he will go for. That is what he will go for. Then on this side, you come and extract the minimums. You come and extract the minimums. So the minimum here is minus 90. Here is minus 40. And this is minus 50. Minus 50. Then I told you here we use the max-min strategy. Max-min strategy. Max-min strategy. Meaning we will pick the maximum of the minimums. The maximum of the minimums, which happens to be this one. Which happens to be that one. So now that the selections are not similar, it means we do not have a saddle point. And if you don't have a saddle point, the next thing that you do is to check whether it is a 2 by 2 matrix. Whether it is a 2 by 2 matrix. Now this game is not a 2 by 2 matrix. It is a 3 by 3 matrix. So when you say no, what you do next is to apply the rules of dominance. And dominance, I told you the other day, is that you maybe I need to capture that. I'm saying no saddle points. No saddle points. That is what I've said. The game has no saddle points. The second point is not a 2 by 2 game. Is not a 2 by 2 game. So apply dominance. Apply dominance. Apply dominance. And when you apply dominance, I told you, you dominate Raja columns. You dominate Raja columns and smaller rows. That is what we call dominance. You dominate or you avoid the Raja columns. So you can start either with columns or with rows. So I want you to do an observation, and of these 3 columns, you tell me which one is consistently bigger than another one, or than the other 2. Which column is bigger? Which one is bigger than another one? When you look at them, tell me the column that is bigger. Eliana says Q2. Aris, which one do you think is bigger? Yes, Eliana. Aris. What Eliana is saying is true. You can see, yes, good Alice. You can see this 0 is bigger than this. Minus 15 is bigger than minus 20. 20 is bigger than minus 50. So if that is true, unakibia hapa, this one you dominate it. You draw a line that. You draw a line that. When you draw a line that way, we now go to dominate the row. So tell me which row is smaller. Without considering what is already dominated, which row is smaller than another one? Which row is smaller? Alice, you are saying Q1. Q1 is not the smaller because you can see this one is not smaller than this. This is smaller than this. I hope you got that one, Alice. It was Q2, not Q1. Is that okay, Alice? Okay. Sasa nataka uniambie which row is smaller. Which row is smaller? Ukiangalia hizi values na hizi, which ones are smaller? None is consistent. Maybe when you are comparing, let me first of all hear from Alice. Eliana is saying none is consistent. Alice, what do you think? Not sure? Okay. You can see this 30. If you began with the smallest, if you're the smallest, yeah? This one is smaller than this, and it's also smaller than this. But when you come here, you find that this one is not smaller than this, neither is it smaller than this. So hii tunaachana nayo. But when you look at K1, the minus 30 is smaller than 80. And minus 90 is smaller than 50. So K1 is smaller than K3. I hope you're able to see that. K1 is smaller than K3. Have you seen that? Eliana, can see that? Alice, have you seen that? K1 is smaller than K3. Yeah. So if we have all seen that, you draw that line, and then you say, down there now you tell us, the game reduces to. The game reduces to. The game reduces to. So we are going to have so this is K2, remember here, and K3. Then we have Q1 and Q3. So this is minus 40 and 80. This is minus 20 and minus 50. So that is how the game reduces. The game reduces to something like that. So I told you, using algebra method, there are 3 steps that we take. There are 3 steps. Step number 1, we will subtract. You can still write. Step number 1 is to subtract. And subtracting, you take the smaller, you subtract it from the higher. So however, it will be 80 minus 40, and the answer is 120. Then for this one, it will be minus 20 minus 50, and the answer is 30. The answer is 30. The second step, I told you, you interchange so that 30 inakuja hapa na 120 inakuja hapo. The last step I told you is the probability. So the probability will be 30 out of 150. And this one is 120 out of 150. That is what you do with the columns. Then you do the same with the rows. You subtract. So subtracting, utasema ni minus 20, minus 40, and the answer is 20. The answer is 20. Then 80 minus 50. The answer is 130. 130. Then you interchange so that we have 130 here and we have 20. And then finally you have the probability as 130 out of 150, 20 out of 150. That is what you do. So if you are okay with that, value of the game, So value of the game, you can have minus 40 times the row probability, 130 out of 150, times the column probability, 30 out of 150. Plus, you take the next one, minus 20 times 130 out of 150 times the column probability, 120 out of 150 plus 80 times the row probability, 20 out of 150 times the column probability 30 out of 150 plus minus 50 times 20 out of 150 times 120 out of 150. So work out that and send me the answer. Work out that and send me the answer. Okay, Rihanna, you are saying you are lost on how we are picking the probabilities. So when you come to this one, for this day of minus 40, unachukua this probability in the row and this probability in the column. When you come to this one, minus 20, you pick the probability in the row and the probability in the column. So 130 and 120. When you come to this one of 80, you pick the probability in the row and the probability in the column. That is 20 DOE and 30 DOE. Then this one for the 50, you pick this one, which is here, another 20, and the one in the column. Is that okay? Rihanna? Okay. I'm waiting for the answer, Alice. Minus 16. Alice has minus 16. I have a different one. Let me confirm. That is minus 40 times 130 times 30 divided by 150. Sorry. Minus 40 times 130 times 30 divided by, getting minus 6.93. Minus 20 times 130 times 120. Minus 13.87. Plus 2.13. Minus 5.33. So minus 6.93 minus 13.87 plus 2.13 minus 5.33. Getting 24. I'm getting 24 minus 24. Alice, I'm still getting the same thing, minus 6.93 minus 13.87 plus 2.13 minus 5.33. Yeah, Eliana is also getting 24. So Alice, you have now 23. Good. So now Marianne. So it's minus 24. Good. So what does that mean? The meaning is because it is negative, is again to error in K. sorry, AR in Q. So tutasema the meaning of that is that AR in K loses 24 while AR in Q gains 24. That is the interpretation. AR in K we lose because are negative. AR in Q will gain. Sharin, welcome. Although we are coming to the end of the lesson. So are we okay with that? So that we can come to the end of the lesson. Rihanna is okay. Alice, are you okay? Welcome. Rihanna, Alice is okay. Good. Sharin, are you okay? Okay, you have just joined and we are coming to the end. Maybe tomorrow you'll come a little bit earlier. So thank you so much. Thank you so much. We meet tomorrow to pick up from there. Thank you. Tomorrow, the same time.